Hello students, so this video is in the continuation of our practice series of chemistry, physical chemistry. In the previous video, we learnt about the physical chemistry part 1. In this video, we are going to cover some of the topics from the part 2 which are provided under our VITEEE official syllabus. So let's look at these topics one by one. If you are new to our channel, please subscribe our channel and watch this video from beginning till the end so that you are able to quickly brush up your physical chemistry concepts and make them strong, and you are very well prepared for your VITEEE examination. And you can definitely ace this examination if you are consistently following us and following our channel. If you want us to bring more and more videos, so like this video as much as possible. We are keeping a very small target of 50 plus likes. So help us in achieving that. It will going to boost our confidence and help us to actually bring more and more videos. Now let's start with our thermodynamics, which is our part 1. So here this topic is important from your VITEEE perspective. First is the first law of thermodynamics, right? So here the energy conservation law. Here is the energy conservation law, which is provided as delta U equals to Q plus W. So this can be represented by delta U is the change in internal energy, whereas Q represents heat supplied and W is your work done. So what is this equation representing us? Key change in internal energy will be equivalent to the heat supplied plus the work done, which we can see from this equation, and this itself is the energy conservation law, which is represented by first law of thermodynamics. So they here from here in VITEEE what we can expect? Direct formula based numericals, especially work in expansion. So work in expansion would be represented by this formula, W equals to minus P delta V. Okay, so you can learn this, you can remember this. Sign convention questions are very common and they are very commonly asked. So these are some of the important points that we need to keep in our mind. So we have understood our first law of thermodynamics. Now let's move on to our second law of thermodynamics. So second law of thermodynamics, what it says, defines spontaneity using entropy. So what is entropy? It is the measure of randomness or disorder represented by the term S. Here entropy, how entropy actually works, key in solid it is less, in liquid it increases, in the gas it is the highest. So entropy increases from moving from left towards the right, from solid towards the gases, right? So measure, it is a measure of randomness or disorder. And second law of thermodynamics defines spontaneity using entropy. The formula for entropy is delta S equals to Q ReV upon T. So this is represented using this formula. This is important from examination perspective. Now, what is the differentiation between the spontaneous versus non-spontaneous? So this is the these are the important conditions that we need to keep in mind. If delta G is less than 0, then the process is spontaneous. If delta G is less than the 0, process is spontaneous. If delta G is greater than 0, the process is non-spontaneous. Whereas if delta G is equals to 0, it will be in the equilibrium state. So remember that delta G less than 0, what it implies? It is the spontaneous process, whereas delta G greater than 0, it implies the non-spontaneous process, and if delta G equals to 0, it implies it is in the equilibrium state. So there is no movement. So this is what we have learned from our second law of thermodynamics. Now let's move on to Gibbs free energy. This is also an important concept from examination perspective. It is represented by this equation, delta G equals to delta H minus T delta S, right? And if there is some standard condition is maintained, so equation turns into this form, delta G epsilon equals to minus RT ln K. So this is the logarithmic form of the equation, right? So this is an important thing that you need to keep in mind along with this equation. What is R representing? It is equivalent to 8.314 joule per mole into K, right? Then T is what? T is here your temperature, it is denoting your Kelvin. In terms of Kelvin, it is represented by this, and K is what? K is your equilibrium constant. So this is how this equation really looks like. And what are the important links? If K is greater than 0, it implies delta G is negative, right? And then the reaction is spontaneous. If delta G is negative, we have already seen this in the previous slide also, and if delta G is positive, which means ki K should be less than 1, and in that scenario, it will be non-spontaneous. If delta G is greater than 0 or it is positive, it is non-spontaneous. Reaction is if a reaction is spontaneous when? If delta G is negative. For delta G to be negative, K must be greater than 1, and for delta G to be positive, K must be less than 1. Hopefully you have understood this also very clearly. In VIT EEE, what type of questions are asked? Usually the direct substitution based numericals are asked, and also sign based conceptual MCQs can also be expected. What is the significance of entropy? It predicts direction of the process, where it is moving, right? So it actually tells us about the direction of the process. Universe entropy increases for spontaneous process. Remember that very important point. Universe entropy, how does it increases? It increases only for your spontaneous processes. So we have understood the significance of entropy as well. Now, as we have learnt about the thermodynamics properly, let's move on to our next topic, which is chemical equilibrium. Very important from the examination perspective. Firstly, the important topic under the chemical equilibrium is law of mass action. What exactly it tells? Ki for reaction, law of mass action would be represented using these equations, AA plus BB, okay, and then these are the reversible processes, CC plus DD, and when this particular reaction can be represented using the K equals to, and here in the numerator these terms are given, this product are given in the denominator, and this is how this fraction looks like. This is the fraction of two products, right? And it is represented using K term. So it is very important. This equation is important from the law of mass action perspective. It is only for the gaseous or aqueous species included. Pure solids and pure liquids are ignored. So remember that only the aqueous or the gaseous species are included. Pure solids or liquids are ignored in the laws of mass action. Then comes the Le-Chatelier's principle, very important in your chemical equilibrium. So Le-Chatelier's principle, what it tells, if equilibrium is disturbed, supposedly ki equilibrium is disturbed, system shifts to opposite change. Okay, so equilibrium is disturbed, then system shifts to your opposite change. Effects are what? If change is how? If change actually takes place in all these formats, and this is the direction of the shift, right? If the concentration of reaction rises, if concentration of reactant rises, then shift is in the forward direction. If temperature rises, if temperature rises, then this is the exothermic change, and the direction of the shift would be the backwards. If the pressure increases in the system of gaseous state, then it will be towards the less moles, whereas if the catalyst is changed, right? So catalyst is in the process, then there is no shift takes place, only the speed is up. Okay, only the speed rises, and elsewhere there is no change. So this is the what the important the Chatelier's principles actually exhibits and tells us the relationship between the change and the shift direction, and these are the effects of these particular changes which we actually observe in terms of the shift direction. What kind of questions we can expect? The predict the direction of the shift. So we need to remember all these factors. Concentration of reactant increases, shift will be forward. Temperature rises, shift will be backward. Whereas in the gaseous, if pressure rises, then it is towards the moles. And whereas in the case of the catalyst, there would be no shift. Kp versus Kc relation can also be expected. So this is the Kp versus Kc relation, important. Kp equals to Kc into RT to the power of delta N. Very important relation. Just you need to keep in mind. You can just by heart it and you understand it properly. So whenever the MCQs are expected, so you can solve them very quickly if that will be in your fingertips. Now let's move on to our third important topic, which is chemical kinetics. So this is also highly scoring. Rate of reaction. How rate of reaction is represented? Rate equals to dA upon dt. So this is the important important formula that we need to keep in mind. It actually shows the rate of the reaction. This is highly scoring. Direct numerical you can expect from this area. Factors affecting rate: concentration, temperature, pressure in gases, catalyst and surface area. These are the 5 important factors that you need to keep in mind: concentration, temperature, pressure, catalyst and surface area. What is the rate law? So rate law tells us rate equals to K into A to the power m into B to the power n. So what m plus n actually represents? M plus n equals to the order of the reaction. How the molecularity is represented? It is equals to the number of molecules in your elementary steps. So this is very important. How the order can be? So order can be 0, 1 or 2 or also the fractional. However, the molecularity is always the whole number. So it won't be fractional. It has to be the whole number. This is an important point that you need to keep in mind, and also the difference between the order and molecularity. We have understood what the order of reaction and what the molecularity and how they are different from each other. Rate equals to K into A to the power m into B to the power n. So hopefully you have understood the rate law as well. Zero order reaction, rate equals to K. Okay, so this is an important relationship. Rate equals to K in the zero order reaction. Integrated form is A equals to A naught minus KT. Important form which is represented using this integrated form. If half life has to be calculated, then T half equals to A naught upon 2K. So this formula is also important. If such numericals are asked from these areas, then definitely these formulas will help you directly, and even you need not to even think twice over this. Hopefully you have understood these portions also from the chemical kinetics. Let's move on to our first order reaction after we have learnt the zero order reaction, right? This is most important. Definitely you can see 1 or 2 questions from these areas. Rate is actually formulated using rate equals to K of A. Integrated form is, when we integrate, is ln A minus ln A naught minus KT. So this is important. And then how the half life looks like. So T half equals to 0.693 upon K. So this is also important. So whenever we are learning about the zero order reactions or the first order reactions, remembering the basic fundamental formula is important. Plus also we need to focus on the integrated form as well as the half life formula also. Here half life is independent of the concentration. So remember that. And definitely VITEEE loves this concept. So definitely you can expect 1 or 2 questions from this area, as previously I have said. Then comes the pseudo first order reaction. One reactant is in the large axis. So remember that whenever we are talking about the pseudo first order reaction, one reactant is always in the large axis, and its example is hydrolysis reactions. It appears first order even if actually it is the second order. So whenever such kind of case arises, then obviously we must be able to understand that we are actually talking about, or examiner is asking about, the pseudo first order reaction. One reactant is larger in excess. Example would be hydrolysis reaction, and it appears first order even if it actually is the second order. How the order is determined? So from the units of K, determination order actually takes place from the units of K. From half life variation, if there is a variation in half life, then also order can be determined, and from the log concentration versus the time graph. So these are the 3 important factors. This is how the order is determined. Then comes one of the most important areas where definitely one question could be expected from this area. If the examiner really want to increase the toughness, or they want to challenge your concepts, challenge your knowledge, then definitely you can expect the question from the Arrhenius equations. So you can pause the video and watch it again. Arrhenius equation is very important. This is represented using this equation: K equals to A into E to the power. This is the exponential form. So A into e to the power minus EA upon RT. Very important. Just write down in your notebook and learn it by heart it. What is the log form? Ln K equals to ln A minus EA upon RT. So this formula is also very relevant. Now here is the two temperature form is also for the Arrhenius equation, which actually looks like ln K2 upon K1 equals to EA upon R into T2 minus T1 upon T1 into T2. So this is our equation. So here once again write it down, understand it properly, what exactly this Arrhenius equation tells us about. So activation energy EA. So this is what the activation energy is. EA equals to energy barrier. Higher EA would be the, what it implies, if the EA would be higher, it implies ki reaction will be slower. So this is the most important point. What actually how it happens in terms of when we are talking about the case of the Arrhenius equation, then higher EA would mean the slower reaction, activation energy EA it is. So it actually acts as your energy barrier. This is the equation, two temperature form. This is your log form and this is your main equation. So hopefully you have understood this also in the chemical kinetics. Now let's talk about our last topic, last important concept, which is the collision theory. So this is the basic concepts which are asked. So for biomolecular gaseous reactions, proper orientation is required, right? And then energy is greater than or equals to your activation energy, whereas the rate depends on the effective collision. So these are really important points that you can actually quickly brush through them and keep in mind from the VITEEE perspective. What kind of questions are usually asked in VITEEE? Now comes the major part, what we can actually expect from our paper. So basically direct formula based numericals, all the formulas that we have discussed so far, learn them, by heart them. We have discussed the most important formulas that can definitely boost your VITEEE preparation. Identify order from the half life. So zero order, first order, we have already discussed pseudo order also. Okay, so we can be asked to identify order from half life formulas. So those are important. Then delta G, okay, and K relations. So there are a couple of relations also that also we need to learn in. And also the Le-Chatelier's principles. We have discussed how important Le-Chatelier's principle is, plus the Arrhenius based temperature change numericals. In the previous slide only, we have taken a closer look at the Arrhenius equation based concept. Very deep derivation not asked. So definitely we need not to go into the depth of the derivations and unnecessarily waste our time. So these are the important things. What is the final preparation strategy? Memorize all the formulas. You cannot negotiate on learning the formulas. By heart it. If you are not understanding, just write it down, learn it, just put it in your memory, and whenever the direct question based are asked, you must be able to solve it quickly. So this is the base of the examination. Practice numerical substitution, focus on first order reaction and the Arrhenius equation, revised delta G and delta K and also your K relation properly. Very important. So remember that if you are able to execute all these things that I have told you, then definitely you can do really well in your physical chemistry. Hopefully you have liked it. Now comes the important aspect. Ki, sir, you have told us all these things, and if supposedly I want to prepare my VITEEE preparation in a very structured and organized way, because all these things that you are telling us, definitely it is boosting our confidence, but also I need proper practice and right relevance, right resources, right guidance. So what is the right resource for that? Then don't worry, our 10Q challenge brings to you the India's #1 and most relevant VITEEE 2026 crash course. This is designed by the subject matter experts in consultation with the VITEEE graduates, VIT Vellore graduates, and also this crash course is the most relevant. Why? Because it consists of all the subjects including physics, chemistry, maths, aptitude and English, which is provided under your official VITEEE syllabus. Remember that it includes the recorded video lectures of all the topics including concepts, formulas, problem solving methods, short tricks, each and everything. The mode of teaching is purely in English. You can watch these lectures anytime and multiple times as per your convenience and pace. Also, you can manage your time very well along with your board exams and also other competitive exams. If you are really serious about your VITEEE preparation, then don't waste a single minute. Remember that the mode of teaching is completely in English. Apart from the lectures, you are getting mock test also, question bank also exclusively, plus short notes also, Don't waste a single minute. Visit our website 10qchallenge.in. Below in the description box, you will find the complete details, website link, as well as the procedure for enrollment. Step by step, follow those procedures and complete your enrollment. If you enroll today, you will get a special discount of rupees 1000 off. Go fast and avail that. Below in the description box, coupon code is also provided. If you have any course related query, you can call us at this number 8839737146. So hopefully you have understood the complete details, the only relevant resource which will help you to boost your VIT EEE preparation. It is the complete one-stop solution for all of your problems. Hopefully you will start your preparation from today onwards only if you are serious about the VIT EEE and VIT Vellore. Now let's start the preparation together and clear the exam together, and subscribe our channel for the regular VIT EEE oriented videos like this. See you in the upcoming videos. Tab tak ke liye jai hind. Thank you.